just gonna start recording now. So, um, so we're gonna finish this question paper. I think we have enough time to finish it because there's only like 3 questions left. So yeah, we're gonna go through question 9 and 10, possibly 11 if possible. But I can't promise that I remember all this stuff based on magnets. But I'll try to help you. But in your part, I don't think you guys really need that many. You guys don't do any calculations in magnetism. So I think that's just gonna make it easier because it's only theory. So they say four metallic bars suspended freely over a ceiling interact, as shown in the diagram below. The point the points of attachment of X and Y on the ceiling are 4 centimeters apart. And the two bars in the middle are bar magnets X and Y, and the distance between them is 5 centimeters. One of the bars, A or B, is made out of iron and the other is made out of gold. So they say write down the term describing material that's easily magnetized. They say which one of the bars is made out of iron. So they even show you like the North Pole and stuff. And they say determine the polarity of bar B closest to magnet Y. Is it north or south? Yeah. So that's why I just said it's magnetism. The term I'm not sure about the term, but do you guys like have any suggestions on the term, like which term can be used to describe a material that's easily magnetized?
So I said ferromagnetic.
Ferromagnetic. Oh man. I don't even remember the last time I heard that word, but I know I've heard of it. So ferromagnetic. Let me just search it here. Ferromagnetic material, a property which results in a large observed magnetic permeability. Ferromagnetic material that displays strong magnetism in the direction of the field due to the application of a magnetic field. So yeah, since it's ferromagnetic, even like the definition online describes it as it's easily magnetized. There they say it displays strong magnetic properties. So they say which one of the bars, A or B, is made out of iron. So just out of curiosity, can you attract gold?
No, sir.
So this is basically like if you know the properties of like gold and iron, you can see that the interaction between X and A, it's like there's no interaction between X and A if you look from the looks of it. So just from X, you can see this is your North Pole, this is your South Pole. Like X is moving towards A, but A is not moving towards X. That means A is not being attracted by X, and A is also not moving away from X, from the magnet. So that means it's not attracted nor is it repelled by the magnet. That means like there's no there's no interaction with the magnetic field between the material that is used to make A and the magnet. So since you know that gold is not that is not like does not display strong magnetic properties, you can see that A is probably the one that is made out of gold. And you know that iron is easily attracted, so it has strong magnetic properties. That's why you can see for B is actually being attracted to the magnet that is Y. The interaction between B and Y, you can see there's an interaction. It's being attracted. So that means B is most likely made out of iron than A is. So I'm pretty sure we understand that part. So
Yes, sir.
yeah, so they say determine the polarity of the bar B closest to the magnet Y, right, north, or south. So as you can see, X and Y, like the separation above and the separation here is different. And when you look at the directions, you can see that X and Y are repelling each other. Is that right?
Yeah.
Yeah. So X and Y are repelling each other. So that means the poles that were next to each other are alike. And you know, like poles are gonna repel and opposite pole, unlike poles, are gonna attract. So that means when you divide Y into two, this is gonna be a south pole because they have to repel each other, and this is gonna be a north pole. But B is being attracted towards Y, meaning it's being attracted towards the north pole. And the pole that is attracted to the north pole is your south pole. So when they say determine the polarity of the bar B closest to the bar magnet Y, it has to be south because it's being attracted to the north pole. And as we established above, B is being attracted to Y. As you can see, like they're coming closer. So do you understand that? I don't know if it makes sense.
Yeah. Understand.
Yeah, so they're like explain for 9.4, 9.3. I already did that.
Can you just say opposites attract, or
Sorry.
can you just say opposites attract each other? Like
Yeah. But
okay.
but you can say opposites attract to each other, né? Then you have to state that the X and Y are repelling each other, and the expo actually you have to explain what's happening here first, the repulsion between X and Y.
Oh, and then
So
after
you can
that
so you
you
can
tell
see, yeah, you can justify why you're saying this is the North Pole and this is the South Pole, because it all
okay, I see
starts
that.
here, so that you can justify what
Mm,
you're saying here. You understand it?
yeah.
Okay.
Yeah.
So in 9.6, yeah, sorry, they say sketch the magnetic pattern of bar magnet X. So I'm sure you guys already know how to draw the the magnetic field lines, right? So it's always gonna be going so this is a question for you. Do you know the direction that the magnetic field lines travel? Is it from north to south or from south to north?
I think it's from north to south.
Hendrix, what's your opinion?
I agree with Trevor, sir.
Okay. And of course, it's gonna be from north to south, so it's gonna be a little something. That's terrible. Let me just use this red one, so it's gonna be something like this. Then you're gonna have two coming out here. Obviously, this is like a more simplified version, so it depends on how many lines you actually want to draw. As long as the lines don't touch, it's fine. So you have to indicate the direction as well. And this one is gonna go in, and this one is gonna go in. So that's how you're gonna indicate your magnetic field lines. So I'm sure you guys are able to draw these, right?
Yes, sir.
Okay. So just remember the direction and make sure that the lines going out and going in, they don't touch at any point. Same time they touch, your answer is wrong. And you have to indicate the direction also. So they say bars A and Y are now removed, and the points of attachment are now 2 centimeters as shown in the diagram below. So they ask you, how will the change in the position of the attachment affect the final distance of the separation between the bars? Is it gonna be greater, less than, or equal to 5 centimeters? So you can see here, it's 4 centimeters. The distance is 5 centimeters. But now they brought them closer. Do you think the distance between them is gonna be 5 centimeters, less than 5 centimeters, or more than 5 centimeters?
Less than 5 centimeters, sir.
Okay, can you try to give a reason as to why?
So because the distance between them is less, and also the bar B is not there, so Y doesn't pull towards B.
Yeah, so why isn't like pulled, isn't attracted to another metal? So yeah, there's the only force in this particular case is going to be the force of repulsion between the two bars. And here there were two forces, because it's going to be the force between the interaction between the two bars, the force of repulsion, and there's also the force between the interaction of the bar Y and bar B. So yeah, it's less force being used to separate X and Y. So we're gonna go to the next question. Let me just quickly erase this. So we're gonna go to question 10. So they say two identical insulated spheres X and Y are suspended by a thread from a ceiling and are held at a small distance apart as shown in the diagram below. The sphere X carries a positive charge and Y has an excess of 30 electrons. So in this particular case, they want you to use the charge of an electron in order to determine the charge of the sphere. So they say they want you to calculate the charge, the magnitude of charge of Y. So I'm just gonna go straight into that. So they say it has an excess of 30 electrons. So you know electrons are negatively charged, right? I'm sorry.
Yes, sir.
Yeah, so
Yes.
so you're gonna go here and find the charge of an electron, which is negative 1.6 times 10 to the exponent negative 119. So you're gonna take your 30 electrons, sorry, and multiply that by the charge, which is 1.6 10 to the exponent negative 19. Then you're gonna get your charge Y. Let me just look for my calculator real quick. So since this is a 3-mark question, usually they want you to like state the formula, substitute, and get your final answer. So what you can do to get like the maximum amount of marks, because if you just go straight to this, your teacher might penalize you. So what you can do is say the charge of Y, which is charge is mostly indicated by Q. So Qy is gonna be equal to, you can say number of electrons, or you can write it down in full words, but I usually just write number of electrons like this, multiplied by the charge of an electron, QE, or whichever symbol they use in the formula sheet, because here they just used E. So you can say you can just write this down, then substitute this down here, and then you're gonna get your QY. So here you're gonna substitute this into being like QY is equal to, let me just erase something. Erase that. Then you're gonna get your final answer where QY is equal to negative 30 times 1.6. So exponent negative 19 negative. So I got negative 4.8 times 10 to the exponent negative 18. 0.18 columns. So for 3 marks, you can say like your equation is a mark. This is your substitution, that's going to be a mark, and your final answer with the magnitude, that's also another mark. So always look at the number of marks that they want to give you, so you can determine how many steps you need to have in your equation, in your calculation, sorry. So they say the spheres are now released and move towards each other. Give a reason why they're gonna move towards each other. So you can say X is positively charged and Y is negatively charged, and opposite charges will attract, and that attraction causes them to move towards each other. I'm sure this is like a very lengthy explanation, but it's for 2 marks, so you have to explain as far as possible in order to get those marks, because you can't risk losing marks. They say the spheres are allowed to touch each other. After touching, they move away from each other. So they want you to state the principle of conservation of charge in words. So charge is conserved in an isolated system. That's basically what it says. And they say calculate the charge on each sphere after they have separated. What's that equation? So you can just use this. So I think both of the spheres have the same. They have the same charge, but it's just it's just like a negative. That one is negative and the other one is positive. So you're gonna have 4.8. So positive 4.8 plus negative 4.8. Divide that by 2. You're gonna get 0 divided by 2, I think. And at the end of the day, your charge is gonna be 0 columns. I don't know if you need me to write it down, but I'm pretty sure you can understand why I'm saying this. I'm sorry, can you understand why I'm saying your final charge is gonna be 0?
So
No.
the negative charge and the positive charges are like the same, so they'll cancel out.
Trevor, our equation is Q1 plus Q2, right?
Yeah.
Divide that by 2. That's how you find your charge, right?
Yeah.
So this is negative. This is negative 4.8 times 10 to the exponent 18, right?
Yeah.
This is positive. Oh yeah, this one
Oh,
is
it's in the
positive
count.
4.
Yes,
Oh, I'm
yes, yes.
sorry. This is 4.8 and this is 4. I'm sorry about that. So if you take out your calculator, you're gonna
Yeah.
have your positive 4.8, your negative 4.8. You're gonna end up with negative 0.8. Because if you take 4.8, if you're gonna take 4, sorry, if you're gonna take 4 and add negative 4.8 to it, you're gonna end up with 0.8. Then that's gonna be divided by 2. So the final charge on each sphere is gonna be negative 0.4 times 10 to the exponent negative 18. 18 columns. So do you understand it now?
Yeah.
Okay. So I'm sorry about that. Maybe I rushed a bit. Negative 0.8 10 to the exponent negative 18. So we have 20 minutes left. What I'm gonna do is I'm gonna stop recording. So stop.